My screen is visible?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Be interactive, otherwise it affects my performance. Clear? If you
Okay, ma'am.
are able to understand, then yes. If no, then say that we are not able to understand. Clear? Yes. We have done the theoretical points yesterday. What is arch? What is garch? Everything was clear? Yes. You have to download RU Garch, F Garch, and FinTS. These three packages you have to install. Install please, because I have already installed. I have installed. See, I have installed these packages. Please install the package. Any one of you may share the screen. Any one of you will be able to share the screen or not? Participants. Any of you want to share the screen or not? No? Yes or no? Yes, participants, yes or no?
For me, no, because I am actually watching it in mobile and doing it in laptop. So it
Okay.
is.
Okay. Any other? No. Okay.
Ma'am, I'm
My
more
screen.
comfortable in EVIEWS.
Yeah, yeah. What are you saying? I'm not able to understand. Yes,
Ma'am,
Pratibha.
I have done the analysis in EVIEWS only. So I'm not using R.
Uh, you are not using R. You have downloaded
Yes.
R. You
Ma'am,
have downloaded R.
I'm doing the analysis in EVIEWS only. I'm comfortable in EVIEWS only.
You have downloaded R or not? My question is,
Yes, ma'am.
you have installed.
Yes, ma'am.
Okay. See, I have installed all these three packages: RUGarch, FGarch, FinTS, Financial T Series. Yesterday we ended our session on this, that you should install these packages. Yes. All the data files we have worked till now are available in environment. Clear? Clear, participants? We have not, we need not download or import again and again. For example, this matched. Clear? I want to do with this work match. Clear? Click it, and on this, you are seeing where is my cursor. You are able to see where is my cursor.
Yes, ma'am.
Click on it and see. Matched data file has been shown. In console window, there is view matched. Clear? Already there is FR and SR. Returns are already there. Future return and spot return. Point is clear or not?
Yes, ma'am.
Bacha, point is clear or not? In environment, global environment, on this we can import data set again, or with the help of this we can do this data set. Clear? Clear,
Yes,
participants?
ma'am.
Yes,
Yes.
ma'am.
Already calculated FR, futures return and spot return. Now, in history, all the commands are there. Sorry, bacha. Hello. Actually, again,
Yes, ma'am.
I'm also working with a desktop, not a laptop, and power cut for some seconds. Let's wait for, yes. Visible? My screen is visible?
Yes, ma'am.
See,
Yes, ma'am.
all the commands are there in history. If you don't delete this, these will be available in the history. All the commands you applied till now, you will get in the history. Clear? Now, you can, for example, you want to run this command again. I have deleted many commands, almost all the commands. For example, you want to run this command again. Yes, select this command to console. This is console. This is source. Clear, bacha? My point is clear or not? This
Yes, ma'am.
first
Ma'am,
left hand side, it is source. Left hand side's topmost part. R is divided, R window is divided in 4 parts. Topmost part on the left side, it is source. Lower part is console. On right side, it is environment. And here we see files, plot, packages, help, viewer, etc. Clear? This is
yes, ma'am.
under history. You will be getting, you will be seeing there are so many commands. Clear? Under history, there are commands. If you want to apply any of these commands again, select this to console, enter. Clear? Clear, bacha?
Yes, ma'am.
Yes, ma'am.
To console, enter. Clear? Clear, bacha? You may save these command
Yes,
also.
ma'am.
For example, view M. I have created a data frame with this view M, enter. See, we are able to see this data frame. On source window, see, there is now another file. Clear or not? Point is clear or not?
Yes, ma'am.
If you select any
Yes, ma'am.
command, if you select any command and transfer it to source, you may save these command also. Okay. Okay, participants. I have saved
Yes.
today's command for simplicity, for convenience. I have saved today's command in this Garch model commands are. With the name Garch models command are. Clear? All commands for today have been saved. First, we want to check whether our series is stationary or not with the help of ADF. What is augmented Dickey-Fuller test? What is augmented Dickey-Fuller test? Dickey-Fuller test checks whether our series is stationary or not. DF, Dickey-Fuller. Dickey-Fuller test checks whether our series is stationary or not. Means our series, whether our series, if for example, y is equal to a plus b y t minus 1 plus u, sorry, plus I'll be increasing the size u t y t means if we regress any series on its own lag, clear? Point is clear or not? And this B is 1. What is the null hypothesis for Dickey-Fuller? It is series has a unit root.
Unit root.
Series has a unit root. What do we mean by unit root? Means its root. Its coefficient is 1. Unit means 1. Root means coefficient. It has unit root, means its coefficient is 1. B is equal to 1. Then we say that series is non-stationary. It is Dickey Fuller test. Then what is augmented Dickey Fuller test? In Dickey Fuller test, test was on only one lag. Then in augmented Dickey Fuller test, previous lags were also added. That is why matlab lag 1, lag 2, lag 3, lag 4, lag 5, other lags were also added. That is why it is called augmented. Miss Dickey Fuller augmented his test by including more lags. Clear? That is why it's called augmented Dickey Fuller test. We want to check whether our series matched under matched FR series, whether it is stationary or not. We will apply ADF under the package T series. View matched to console means show us the matched file. Now I will be running this command T series ADF. I am selecting this command, Control C and Control V. Enter. Clear? Yes. Null hypothesis is series is non-stationary and p value is less than 0.05. Less than 0.05 means series can be null hypothesis can be rejected.
Yes, ma'am.
Null hypothesis is
We can
series is
reject the
non-stationary and it is
Yes, ma'am.
rejected, and alternative hypothesis is that series is stationary. So we may say that this series is stationary. Yesterday we were discussing that Garch family of models is applied on stationary series, means we can now apply on this FR futures return series under the file matched. Clear up to now? Clear up to now, bacha?
Yes, ma'am.
Yes. But we have to check whether there is arch effect in the residuals or not. We will be, I am applying regression model ARIMA matched FR order C000. I shared with you yesterday in the evening that this is the command if we want to apply regression on C, AR model on C. Clear?
What to do if there is unit root in the series? How do we
That
resolve?
we will difference it. Clear?
Take the first
See
difference.
in the matched series, if we check for this metal futures close, let me check for this whether it is under matched file. Let's check metal future close. It is stationary or not. See this? P value is greater than 0.05. Null hypothesis cannot be rejected, means series is non-stationary. But when we calculated the return for the same series, this series
It is
was
a stationary.
stationary.
That means it is stationary at first difference.
Yeah, it is stationary at first
So
difference.
while reporting, we'll mention that it is stationary at first
Yeah,
difference.
yeah, we have to mention. We converted this series to, we took the log difference of the series to make the original series stationary. Clear?
Okay, ma'am. And in
Because
case if it is not stationary at first difference, also we'll take second difference then.
yeah,
Okay.
clear.
Okay.
But some models are not applicable on second difference stationary. It is something advanced. Clear? For example, we can't apply ARDL model on second
We can't
difference station.
apply RDL on second
Clear?
difference model.
Yeah, yeah.
Okay.
Let's apply our model. Our model name is LR. LR ARIMA means we are applying in the EVIEWS we applied a regression model on C, on constant only. In the same way I am applying, my model name is LR ARIMA matched FR order 0 0 0 means it is constant. 0 AR 0, I integration 0 and M is 0. Enter. Now show me the coefficients of LR. Yeah, we may write summary of LR, or we may say coefficient of LR. Clear? But when
Yeah.
we apply on intercept, it is better to see the coefficients rather than summary. Clear?
Yes, ma'am.
Clear? Up to now it is clear. Now
Yes,
we
ma'am.
will be checking whether there is arch effect in the residual of my regression equation or not. My regression name is LR. For checking the arch test, we have done it already in EVIEWS. Steps are same. We applied our regression equation on C. Then we are checking whether there is arch effect in residuals or LR, residual of my regression equation. I have given this the name LR. You may give any of the name, any name of your choice. Yes. Null hypothesis is no arch effect and p value is less than 0.05. E minus 16. We already discussed what does it mean. E minus 16. We shift the decimal point to 16 points towards
16
left.
degrees left.
C value is less than 0.05. Null hypothesis will be rejected and null hypothesis is no arch effects. Clear? Means arch effect is there. Arch effect is there. Clear up to now?
Yes, ma'am. Yes, ma'am.
Yes. Now we are going to apply Garch 1 1. The same way we applied it. This is the, sorry. Command is I think that command has not been copied. Yes. Or it was, yes. This is the command. LFRG is my model name. RUGARCH is package. Under this RUGARCH, I am applying GARCH model. UGARCH SPEC. It is for GARCH model. I am specifying my variance model list. SGARCH. SGARCH means standard GARCH. SGARCH means standard GARCH. Check S is in small letters, because R is uh, case sensitive. So we have to check which alphabets are in small and which alphabets are in capital letters. Yes. Order, Garch order, it is 1 1. Garch order is 1 1. Mean model, what is my mean model? What is my mean model? I am applying ARMA order C11. Clear? You may apply same order C00. Clear? Now enter. Now specify on which series you want to apply this model. Under RU Garch, U Garch fit on the series. Which series? Which model you want to apply? LFRG. What is this LFRG? It is my model name. See, it is my model name. I have given that apply LFRG. The model I have already specified on which data? On FR series under matched file. We have to specify first our Garch model, then we have to specify on which series we want to apply this Garch model. U Garch fit. This is your model name. LFRG. Then on mesh FR, enter. Yes. These are the results. S Garch means standard Garch. See, we have mu, AR1, MA1, omega, alpha, beta, then this mu, robust standard errors for mu. What does these mean? See, mu. Mu is the intercept of mean equation. Yesterday in EVIEWS, there was intercept in mean. There were two equations. Mean equation and there were two equation or not?
Yes, madam. Mean equation and
Yes.
variance equation.
Mu is intercept of mean equation and omega is intercept of variance equation. Then alpha 1, it is the coefficient of lagged residuals. What does coefficient of lagged residual in variance equation tell us? I told you yesterday, it is arch term. Clear? Interpretation is same, but coefficient name here is for arch, here name is alpha 1. Yesterday it was arch. In EVIEWS it was arch. In R it is alpha 1. It is arch term, coefficient of arch term. It tells us about the spikes. I told you the same interpretation, whether news has any impact on conditional volatility or not. Clear? And beta 1. Beta 1 is coefficient of lagged conditional variance. Same, which was in EVIEWS it was Garch term. Alpha
Yes,
1.
madam.
In EVIEWS it was arch term. Beta 1. In EVIEWS it was Garch term. Interpretation will be same. Clear? Clear, participants?
Yes, madam.
Yes. Now let's apply GJR and EGARCH. We already learned these models in EVIEWS. Now let's apply these model in R. See, it is the same model. Only the difference is this S, standard GARCH, this S letter has been changed with small GJR. Clear? Model is same, but this only this this S has been replaced with GJR. Clear? My point is clear or not? My point is clear or not?
Yes, madam.
See, I have this model as GARCH. Select this to console and change this SGJR S with GJR in small letters. Press enter. Then are you fit? Same. Yes. It gave us the result for GJR model. Clear? Now interpretation AR1, MR1, these are AR, MA, same terms which were in, this is mean equation. These first three terms are mean equation. Yes. Alpha, omega, already it is constant coefficient of or constant of variance equation. Alpha 1, it is arch term. Beta 1, it is Garch term. This gamma 1, it is a symmetry term. Clear? Yesterday, what did we see? It should be in GJR model. It should be positive and significant. Clear? Yes,
Yes, madam.
participants. It should be positive and significant. These are the values. See, these are the values. This is the model, actual model. MU, what is MU? It is constant of mean term. AR1, we applied the model on AR1. MA1, we applied model on MA1. Omega, it is
Constant of
the constant of variance term. Alpha, it is for arch
arch
term.
term.
Beta, it is for Garch term. Gamma, it should be positive and significant. It's not positive and significant. So it should be positive and significant or negative and significant. In GGR, it should be positive or and significant or negative and significant. It should be positive and significant for GGR model. I'm not able to recall. It was positive and significant yesterday, or it was negative and significant. Yes, participants in GJR model. आप लोग नोट नहीं करते हैं? हाँ जी. It should be positive and significant or should be negative and significant, because हाँ जी, what is news? What is asymmetry? Participants, for leverage effect, it should be positive and significant. Yesterday, I told you that for bad news impacting more than the good news, this term should be positive and significant. See, let's check. It's not positive, it's negative and insignificant. It's insignificant, so no interpretation. Means in this case, news has no impact, no asymmetric impact. News has no asymmetric impact means positive news as well as negative news has same impact on the volatility. Clear or not?
Yes. It's
Clear?
symmetric impact.
Yeah, it is asymmetric, not asymmetric.
Yes, madam.
Yes. Let's now apply EGARCH. Same command C. In SGARCH, I'm converting this S to E. I'm converting this S to E only. Otherwise, model is same. And yes. For EGARCH model, yes. For EGARCH model, whether this asymmetry term should be positive and significant or negative and significant. For EGARCH model, what should be the effect? Yes, participant.
And both positive as well as negative and significant.
No, it should be negative and significant. For EGARCH model, it should be negative and significant. For GJR, it should be positive and significant. See, what are the results? Results are different, reverse. We are getting the different results. Positive and significant means positive news has more volatility in this case than the negative news. Clear?
Yes, madam.
Clear or not?
Yes,
Ma'am,
madam.
repeat it again, please.
Yes. First of all, let's discuss what is EGARCH model and what is GJR GARCH model. Yes. What is asymmetry? हाँ जी
Tells
बच्चा.
us the behavior. Ma'am, it tells us the behavior of negative and positive value. It is the same way or not?
Yeah. Means negative news impacts the volatility more or not. Generally, the presumption is after negative news, volatility is more than the negative news. Clear? Clear?
Yes, ma'am.
Yes.
More than the positive.
More than the positive news. Clear?
Yes.
In comparison to positive news, negative news has more impact on volatility.
Yes, madam.
Clear?
Yes, ma'am.
In GJR model, this asymmetry term, it should be positive. GJR model is the in the way that it should be positive and significant.
Positive
Clear?
and significant.
In
Yes,
GDR
madam.
model.
And what does it
And
imply?
What do you want to ask? Please clarify.
And what does
That
it
is
imply
bad.
for
Bad news affects more than the good news.
that's in the case of e-gas that negative news have more
Negative
More
news has
impact on.
more impact on volatility than the positive news. Clear? I have shared with you this file.
yes, ma'am.
Yes. See, in E-Garch model, what is expected? E-Garch and GJ-Garch model. These are the packages. This gamma term, E-Garch term, this gamma term. This is the real model. Clear? Gamma 1 captures this. Point is clear or not?
Yes, madam. Clear.
Yes, see. Results are in this form and this series, results are same that were in our series. Gamma 1, it is positive and it is on different series. Gamma 1, see, gamma 1, it is positive and
Significant.
significant. Means good news has more impact on volatility than the bad news. If it is negative, means bad news has more impact on volatility than the good news.
Good.
We expect it to be negative and significant. Clear? Clear, bacha?
yes ma'am.
Okay,
Yes,
ma'am.
ma'am.
Yeah.
Yes,
But
ma'am.
in
Yes.
our case, it is positive. See, it is positive and significant means good news has more impact on volatility than the bad news. If we have simple optimal parameter as well as robust standard errors, with robust standard errors, we should go with this table with robust standard error. Clear? Clear, participants?
Yes, ma'am.
Yes.
Standard error model.
We have applied, Anji. Yes, we have applied. See,
When we
he's
apply,
saying the results of EGART in the result of EGART symmetry term is the positive to what would have been expected in the case of application of GARCH model. Opposite to what means we expect it to be negative. Clear? Clear cut. It is given in
hello,
the even
hello,
in this file that we expect it to be negative, but it is positive. Yes, Hanji.
madam. I have a query. Actually,
Yeah.
I want to. When we interpret the robust standard error model, when
Why
we
should
interpret the
we
robust,
interpret what are robust standard errors? Means if there is autocorrelation or uh, autocorrelation or volatility, then
it is
these standard errors are, see what is the difference between these two tables. I'm copying this and pasting one Word file. Oh, sorry, on Excel it will be better comparable. These are without robust standard error and these are with robust standard error. What is the difference between two? We have already discussed it, whether it has changed or not. This estimate has changed or not?
No, ma'am.
no,
Not.
ma'am. Actually, p-value
Standard
is
error
changed.
has been changed or not?
Yes, madam. Standard error has been
Yes,
changed,
ma'am.
and according to the p-value has been
P-value
changed.
has been changed and p-value has been changed. It is giving us robust standard error, means corrected for any known normality or volatility or uh,
Yes.
autocorrelation. It has corrected for those problems which are in our residuals. Clear?
Oh,
So we should go for these. If these are available, we should go for these. My point is clear or not? We should interpret these results because
Yes,
we
ma'am.
see that in coefficient is same, but standard error, t values and p values are different. Clear?
yes, madam.
Now I think everything is clear about Garch models with R. It should have been covered yesterday. Clear or not?
Yes, ma'am. All clear.
Yes.
Yes, ma'am.
Let's today we'll be sharing with you this. Yes. Let's check Fred this file with EVIEWS. FRED. I shared this file with you. These are interest rates. These are interest rates. Open this file with EVIEWS FRED. Fred. These are interest rates. 3 month, 5 months, 6 months, 1 year, 3 year, 10 year. These are interest rate. We have 6 series. GS1 1 year rate, GS3 3 year rate, 10 year rate, 3 months rate, 5 year rate, and 6 months rate. Clear? I'm opening this series together. Now, if sorry, what is VAR, ECM, and VECM? We discussed about simple regression equation or ARDL model, ARMA model, ARIMA model. All are clear to you or not? What is the difference between ARMA and ARIMA?
Ma'am, in ARIMA model, we take the series which has been difference. Like we have taken the difference of the series.
Linear regression model or least square regression model. Then ARDL and ARIMA, then ARMA. Yes. Linear regression model or least square regression model or ARDL model or ARIMA model or ARMA model. In all these models, we know what is our dependent variable and what is our independent variable. Clear or not? In linear regression model, the main condition regarding variables was that our dependent variable should be on ratio scale or interval scale. It was or not? In
Yes, ma'am.
ARDL and all should be stationary. For time series data, if we want to apply linear regression model, it can be applied on stationary data. ARDL model, it can be applied on stationary data. See, stationary data. stationary data, it is denoted as I0. I0 means it is integrated of level 0, means it
Yes.
is stationary at level. Clear?
Yes, madam.
Non-stationary data, it is denoted as I1
1 or I2, etc.
or I2 and so on.
Yes, madam.
What does it mean? Means I1 means it was non-stationary in level, but we differenced it to make it stationary. Clear?
Yes, madam.
I2, it was non-stationary in level. We have to difference twice to make it stationary. Clear?
Yes, madam. Yes,
ARDL
madam.
model is applied on I0 and I1 models. I0 and I1 series. ARIMA model means we are applying ARMA model, but on integrated series means we converted the there is we are applying AR model, AR and MA model on. See,
Different.
it is for example it is 1 0 1. What does it mean? Means one AR term and
Yes, madam.
integration of
Yeah,
level 0 and one MA term.
1
Clear?
madam.
If integration is level 1 1 1 1, what does it mean? Means we introduce one AR term, integration of level 1 and one MA term.
Yes, madam.
In all these four models, we know what is our dependent variable. Means we were able to write y is equal to a plus
Yes,
bx plus cz and so on.
yes, madam.
Here, what if we have two series and we don't know which series is impacting the other series? There may be feedback relationship. There may be feedback relationship or not. For example, in the example of lady and dog, we can see sometimes lady is holding the dog, and sometimes dog is um, controlling the lady. Means dog is able to take the lady to the side he wants to go. Clear?
Yes, madam.
For example, you are two friends. What relationship may be there regarding taking decisions? You have two friends, A and B. One possibility is A takes the decision and B follows. Second possibility is B takes the decision and A follows. And third possibility is both. Sometimes A
Yes,
takes the decision and B follows. And sometimes B takes the decisions and A follows. Possible or not?
yes, madam. It is possible.
So we don't know whether relationship is of this type, or of this type. We don't know what is our dependent variable, which type of relationship is there. Then we have to go for VAR,
Or,
Granger causality, or error correction model. What
yes,
is the
madam.
difference between VAR and Granger causality? Both are almost same. Both are almost same. Just the difference is Granger causality can be applied only on two series. Pairwise Granger causality can be applied. Means if we have three series A, B, and C. Granger causality will check relationship between A and B and C, and C and A. Granger causality will check relationship between A and B, then B and C, then C and A. Means only Granger causality can check only pairwise relationship.
Otherwise,
Clear?
yes, madam.
But var can uh, means for A as dependent variable only either B can be independent variable or C can be independent variable. But var applies, in this case, var will apply three equations. One, A as dependent variable, B and C as independent. Second, B as dependent variable, A and C as independent variable. Third, C as dependent variable and A and B as independent variable. Point is clear or not? What is the difference between var and Granger causality? Point is clear or not?
Yes, ma'am.
Yes.
Yes, ma'am. Ma'am, this
Yes.
possibility of checking the nature of series taking as independent or dependent variable is available only in time series or it is available in other forms
Only
also?
in time series.
Okay, okay, ma'am. Thank you so much.
Matlab, as far as I know, it is available only in time series.
Okay, ma'am.
because
Thank you.
because I work with mainly with time series. It is the first time I used cross sectional data in my workshop. Otherwise, all the times I prefer time series data.
Okay, ma'am. Thank you, ma'am.
Hello, madam. It is also
G,
possible in case of panel data because it has a time dimension.
yeah, I think because feedback in this case it takes lags. VAR and Granger causality take lag. So generally we think that these are available only for mm, time series data because
And panel
lags
data.
are in time series data.
Yes, madam.
Clear?
Yes, ma'am.
Yes. What is the difference between VAR and Granger causality? I told you that Granger causality
Works in
works pairwise, whereas
Otherwise,
VAR can apply for more than two series also.
two
Clear?
variables taking one dependent and others independent.
Yeah. Please repeat your question.
Actually, madam, I want to say in case of Granger causality, it is actually the pairwise comparison
Yeah,
of
it is
dependent and
pairwise
independent.
comparison. Clear? But both are applicable. VAR and Granger causality, both are applicable only on stationary series. Clear? VAR and Granger causality, both are applicable only on stationary series. We can't apply these to non-stationary series. Clear?
Yes, madam.
Yes, ma'am.
Yes.
Excuse me,
Yes.
ma'am. Stationary may be same order.
No. Stationary may not be of same order. It may be of different order. Stationary of level 1, level 2, I1, I2, but it should be converted to stationary. Clear?
Okay.
Generally,
Yes.
I2, for I2, a separate model, not model, a separate test is available for I2 series. Generally, we don't find I2 series in our data. Clear? Yes. Let's check GS1 and GS3. Open GS1 and check whether it is stationary or not. Unit root test. First of all, let's check its graph, whether there is any outlier in the series. No outlier. Yes. View unit root test GS1, standard unit root test, because we are not observing any breakpoint in the series. Standard unit root, augmented equifuller, select automatically. Yes. GS has a unit root and it is rejected. Means series is stationary. Null hypothesis is that stationary is known, series is non-stationary and p-value is less than 0.05. We may reject the null hypothesis. Means series is stationary. Clear?
Yes.
GS1 is stationary. Let's now we check GS3. View graph for checking any outlier. No outlier, no trend, particularly G3 view unit root test, standard unit root test. Series has a unit root and null hypothesis cannot be rejected. So we have to convert it to, we have to take the difference to convert it to stationary series. Clear or not?
Yes, ma'am.
Yes,
Yes,
3
sir.
months.
Yes, ma'am.
View, graph, see, no outlier. View, unit root test, it is also stationary. GS1 and GS3M. 1 year interest rate and 3 months interest rate. These both are stationary. Let's apply Granger causality on these series. Go to quick group statistics, Granger causality. Steps are go to quick group statistics, then Granger causality. We are applying Granger causality on GS1 space GS 3 months. It was 3 months, I think. Clear. Okay. Now, the issue is how many lags to include. It is the issue in Granger causality to select the lags, but there is some solution. Open these two series, GS1 and GS3M, then view cross correlation. View cross. What is simple correlation? Yes, participants. What is simple correlation? What is correlation? Correlation means linear relationship.
Between two variables.
बिल्कुल. Between two variables. What is cross correlation? What is cross correlation? Linear relationship between two variables with lags. Clear? With lags. Means whether lag of first, if say this, I'm opening this file, Fred. This series and this series. I'm copying this series and pasting this. If we calculate correlation among this series, it will be simple correlation. Clear? Clear, participants?
Yes.
But if I take lag of one series, means if I write this year, now I calculate correlation between this series and this series. It will be correlation or cross correlation, because I am finding out the correlation of GS1 or of GS3M with the lag of GS1. Clear or not? Clear or not?
Yes, ma'am.
I'm relating this series. I'm taking the correlation of these two series. What is it? This is
Cross correlation.
cross correlation. My point is clear or not? Yes, participants.
Yes, ma'am.
Point is clear. See, it was against 14.32, the value was 12.92. But in this case, 12.92 is against 14.73. Clear? It is cross correlation. Point is clear or not, participants?
Clear, ma'am.
View cross correlation. Up to 36 lakhs. Show us the cross correlation. Yes. See, these are significant. Cross correlations are significant. Lead, lag. This is the lead and lag. Clear? This
Yes.
is with
Yes, ma'am.
-1. This is with 1. On the basis of these series, we may select the number of lags. Okay, how many lags should we select? Yes. Again,
Ma'am,
I am
please
doing
repeat it.
cross correlation. Yes, I am doing cross correlation with 100 lags. These are correlations with lag 1, with lag 2, with lag 3, and with lag 4. Clear? Point is clear or not?
Yes, ma'am.
Clear? Sample is from this and included observation are this consistent approximation. Clear? Or you may go with quick group statistics, Granger causality. Sorry, we have these view Granger causality should be there. Granger causality. You may go with lag 2 only. Is it possible? Yes. Null hypothesis is GS3M doesn't Granger cause GS1. It doesn't Granger cause GS1. What is the interpretation of Granger causality? Any one of you who have already attended any of my or any other workshop on time series? What is the interpretation of Granger causality? It is impact. What is causality and what is Granger causality? What is causality?
That one variable causes the impact on other variable.
One variable causes the one variable has impact on the other variable. How I interpreted lags while interpreting ARMA model or lags? How did I interpreted these? Yes. How I interpreted the lags? That if the coefficient was significant, I told you that this lag is significant in interpreting the dependent variable. It was for the
Yes,
same
ma'am.
lag, but Granger causal it was for the same variable, means y and yt minus 1. Yt is equal to a sorry a plus b by t minus 1. How did we interpret this? How did we interpret this? Lag, if b is significant, what will we say? That lag of yt is important in forecasting yt. Clear or not?
Yes, ma'am.
Now,
And
if
if
we
B
have
is
two
significant,
variables, yt minus 1 as well as xt minus 1, plus xt c x t plus, I'm writing d, it's not generally written, but I'm writing. It is b1, b2, b3. Now, if coefficient of c is significant, we will say that x has impact on y. X is impacting the y. Clear? But if coefficient of D is significant, we will say that X is leading Y. Clear? Clear, bacha, or not?
Yes,
What
ma'am.
is interpretation? In this case, if B is significant, what will we say? That lags of Y are important in forecasting Y. Lag of GDP are important in forecasting GDP. Clear? In this case, if coefficient of C is significant, we will say X is impacting Y, because this relationship is in levels. Clear? Point is
Yes,
clear or
madam.
not? But
Yes,
if
ma'am.
this D is significant, means coefficient of lags of
Like,
independent variable is significant, then we will interpret it is like X is leading Y. Clear? Clear or not?
Yes, ma'am.
Clear? X is
Yes,
leading
ma'am.
Y. In uh,
yes,
in finance or in economics, generally there are many variables. On the basis of one variable, we forecast the other variable. If unemployment is increasing, we say there may be recession or not. Unemployment may not. Unemployment, if for example, industrialists have stopped purchasing new machinery, or they have stopped working on new projects, it causes recession? No, it may be the indication that recession is approaching. Clear? Clear, bacha?
Yes,
Clear,
ma'am.
participants? That is lead lag relationship. Which one is leading and which one is lagging? Which one is leading and which one is following that variable which is leading? Clear? It is the interpretation in econometrics. It is the interpretation in finance. Now, X1 doesn't grandeur cause GS1, sorry, doesn't grandeur cause GS3M. This has been rejected. Means GS1 grandeur causes GS3M. What can we say? Means GS1 leads GS3M. First, there are changes in 1 year rate, then there are changes in 3 months rate. Clear?
yes,
Yes, ma'am.
Means lead lag relationship. Means GS1 leads the GS3M. Grandeur causality means lead lag relationship. Clear? Clear, bacha? Yes.
Yes, ma'am.
Now let's check. It is GS1. It was stationary. Again, I'm checking view, unit root test, simple unit root test, GS1. Note down it is stationary. Now I'm moving towards var. Note down this. GS1 is stationary. GS3. Let's check GS3. View, unit root test, standard unit root test, enter. No, it's not stationary. Then I'm checking GS10. View, unit root test. It is also not stationary. GS3M, we have already checked. Let's check it again. Unit root test. It is stationary. GS3M. Next series is GS5, 5 years rate. View, unit root test, non-stationary. GS6M. View, unit root test, standard unit root test. Okay, it is also stationary. Means we have 3 series: GS1, GS3M, and GS6M. These 3 series are stationary in level. Let's apply var on this. Go to quick estimate var. Go to quick estimate var, standard var, GS. We are writing our series name GS1, GS3M, sorry, GS6M. I'm selecting interval only 2, or you may 1 to 10. Clear? It is arbitrary number. 1 space 10 means lags up to 10. 1 space 12. Start with maximum possible lags. It is monthly data, so maximum lags may be 12. I have started with the maximum lags. I don't have prepared PPT for these points. So you have to note down the steps. Today's recording will be shared because today some participants are looking attentive. Okay. Yes. We are not going to interpret it. View.
Hello, madam. Excuse me, madam.
We will be checking the lags. Yes, Bacha?
Actually, ma'am, yesterday due to technical error, I am not able to attend the first part of the session.
Yesterday it will be shared. Yes.
Okay. Thank you, madam.
We started with बच्चा आप देखिए आपकी क्लास में अगर स्टूडेंट्स नहीं पढ़ रहे होते क्या आप अच्छा लेक्चर डिलीवर कर सकते हैं?
No, madam.
Same is the case with me.
Yes,
You were not attentive yesterday. Many of you were not attentive yesterday. No one was responding. So I was not able to deliver good lecture. Clear? It hurts. Be attentive. We will be sharing.
Sorry. Due to
No
technical error.
no issue, please. Yes. First step was we applied VAR model on maximum lag. Then we are selecting the lags. Go to view, lag structure, lag length criteria. Means now we are checking how many lags we should. It tells us. See, Granger causality doesn't tell us. Granger causality doesn't tell us how many lags to include. There is issue, but this tells us lag structure, lag length criteria. Apply 12. Okay. Yes. It's telling us AIC. AIC says how many lags to include? 6. SC, such large information criteria, tells us how many lags to include. HQ,
2.
it is generally the average of these. It is also telling us go with 2 lags. We are going with AIC and we will be introducing how many lags? We will be introducing 6 lags. Point is clear or not?
Yes, madam.
Yes.
This star indicates lag order selected by the criteria. Means it tells us how many lags to include. You have to write which criteria you are following. Criteria I'll be discussing today.
Madam, in a particular
Yes.
paper, follow AIC criterion, then we have to follow AIC for entire paper, or we can combine the
Yeah. You have to follow one criteria and you have to give the logic why I am following this criteria. Either on some research paper, good research paper, or some good book. There is a book by Walter Anders. Time series applied time series, something like this title. Walter Anders. Walter Anders says for long term, for a large sample, you should go with SC data, SIC, and for small sample, you should follow AIC. Clear? You may quote some book or you may quote some good paper. Clear? Yes.
Yes, madam. Thank you.
Yes. Now, if we are following AIC, we will be introducing 6 lags. If we are following SC, we will be introducing 3 lags. Again, estimate. I am changing here lags from 12 to 6. Okay. Yes. These are three equations. View, representation. See, there are three equations. First equation, second equation, and third equation. You may copy and paste to your research paper. Yes. Yes, these are the results. How to interpret the results? See, in these brackets, these are standard error. And in these brackets, it is T-stat. T-stat is GS is dependent variable and these are independent variable. See, GS1 is significant. GS2 on the basis of T value, absolute value should be greater than 2. Lag 2 is important, lag 3 is important, lag 4 is important, but lag 5 is not important. Lag 6 is also not important. We can say for forecasting GS1, 4 lags are significant. Clear? Clear, bacha?
Yes, ma'am. Yes,
No,
ma'am.
ma'am, please repeat it again.
See,
How are we?
see, it is the equation of GS1. First equation, it is the equation of GS1. Clear? This is the equation of GS3M. 3 months. It is the equation of GS6M. Clear? These are three equations. Let me try to copy and paste in Excel file for comparison. If possible, let's try. Yes. See on EVIEWS results, it's saying in these brackets, what contains? These brackets contain standard error and these brackets contain T statistic. On the basis of T statistic, what is the criteria to be significant? For T statistic, what is the criteria for significance? T statistic should be greater than 2.
Great.
Yes.
Be greater than.
Greater
Yeah.
table value.
This is greater than 2. This is greater than 2. This is greater than 2. This is an absolute term. This is not greater than 2. This is also not greater than 2. See, these are for GS1.
Hello, madam. What is
Yes.
the table value or the table value of T statistics for this particular case?
Generally, p values are not given. So generally we follow T statistic more than 2 is significant. Clear? For large sample, we compare T statistic with 2. Clear?
Okay, madam.
Means these 4 lags of the same. See, it is GS1. This equation is for GS1. See, and these are GS1. 6 lags of GS1. Clear? 4 lags are significant. Means we can say 4 lags of GS1 are significant in forecasting GS1. Clear? But these are 1 year rate. For forecasting 1 year rate, 4 lags of 1 year rate are important. Clear? Clear or not? Now let's see these. First is significant, second not, third is not, fourth is not, fifth is not, sixth is not. Only one is significant. Means we can say 3 months rates lead the 1 year rate. Clear? I told you in this. If D is significant, what will we say? That X is leading Y. Clear or not?
Yes, ma'am.
Same way,
Yes, madam.
this is equation for GS1 and this is the coefficient of GS3M, 3 months. Then what can we say? Because it is significant, T value is greater than 2, we can say that GS3 is leading GS1. GS3M is leading GS1. Or there is some simple way in EVIEWS. Go to view for lead lag relationship. Go to view, go to lag structure, grandeur causality test. Okay. See, this is dependent variable. First equation is for GS1. Second equation is for GS3 months. Third equation is for GS6 months. Clear? Clear, bacha, or
Yes,
no?
madam.
Yes.
Yes. How to interpret this table? This table is for GS1, 1 year. It says it can be excluded. GS3M can be excluded. On the basis of probability, we can say that it cannot be excluded. GS6M can be excluded. No, this cannot be excluded. Means GS3M and GS6M have impact on GS1. Clear or not?
Yes.
Yes, ma'am.
Yes.
Yes,
Means
madam.
these lead GS1. Yes. Now for GS3M, same status is there. For GS6M, same status is there. Means we can say that there is feedback relationship among these three variables.
Hello, madam. I have a question.
Yeah.
Actually, if for example, it is assuming that the GS1 has significant impact, but GS6M has insignificant impact. Actually, in case of probability value, p value, it is insignificant.
For example, you want to say this probability is greater than 0.05. What would we say?
0.05.
Not
Yes, yes.
significant.
And in case
This
of
is
not
your
significant,
question.
and in case
This is your question. If this probability is greater than 0. Let me copy this and paste to Word for
actually, my
changing. Yeah. You ask your question. Now ask your
yes, madam.
question.
I want
What
to
do you
say,
want to
if
ask?
the overall, that in case of all items, if the probability value is significant, but the individual values have insignificant impact, then what will be the interpretation for this particular?
I couldn't understand what you want to ask.
Actually, madam, I want to say, if
In this
the
example, say what you want to say. This is
for
significant.
example, this is significant. Let's say this is significant, and the following
Overall
items
value is not
GSM
significant.
overall is insignificant.
This is significant. This is significant, and overall is not significant. This will not be the case. If if both are significant, this will be significant. If one is significant, then may be the case that this is not significant. Clear?
Actually, ma'am, I want to say this particular case, when one is significant, another is insignificant, and the total is significant, then what will be the?
Yeah. You want to say this is significant. This value I am changing. It is, for example, 0.98, and this is the case. This is your question.
Yes,
This
madam.
is your
Yes, this is
question.
my question.
One
Madam.
is significant, second is not significant, and this is significant. Do you know about T ratio and F ratio? What does we how do we interpret T stat and F stat? What does F stat tells us? F stat tells us that overall model is fit. Clear?
Yes, ma'am.
And T stat tells us this particular coefficient is significant. This particular variable is significant. Clear? Then in that case, this will be interpreted in the same way. Means we will say overall model is significant, but it is because of reason that GS1 is highly significant. Clear?
Yes, madam.
Yes. We will say that overall model is significant. It is because of the reason that this variable is highly significant. This is the interpretation of F ratio or T ratio. This all means F ratio. This tells us about the overall model. This tells us about the individual variables. Clear?
Madam.
Clear, bacha?
Yep.
Error
Ma'am,
correction.
if one
Now
is
let's go
if one
for
is in
error correction model. Our three variables were significant: GS1, stationary, GS1, GS3M and GS6M. And these GS3, GS10 and GS5, these were not stationary. Clear? Let's check whether there is any co-integration among these. What is co-integration? What is co-integration? Lady and dog? One of the
Two
best
series are
examples
moving.
of co-integration means they may be moving towards, they may be moving far apart, but they are moving together. Maximum length is length of the chain. Maximum distance is length of the chain. It is co-integration. Means when two non-stationary series move together, it is called co-integration. Clear?
Yes, madam.
Let's how to select three variables 1, 2, 3. If we want to select variables that are consequently written, arranged, then we may select with the help of shift. But if we want the variables which are not adjacent, we have to select with the help of control. GS1, control, GS3 and GS5. Sorry, GS3, GS5 and GS10. These are non-stationary. Open these. GS3, GS5, GS10. View graph. Okay. What do you say? There may be co-integration or not. This
Yes,
series are
madam. They are
together.
co-integrated each other.
Yeah, there may be co-integration. Graphically, we may say that there may be co-integration among these series because generally these are moving together. Clear? Let's check quick group stat Johansson's co-integration test. View quick group stat and Johansson's co-integration test. Johansson's co-integration test is for this co-integration. Okay. Now what to do? Whether we should say there is no intercept and no trend, or there is intercept or no trend, or which one to select? 1, 2, 3, 4, 5. Which one to select? If I am able to decide which one to select, then I'll be selecting this. But if I am not able to decide which one to select, Pentula, a researcher, said that you go for all these. Summarize all the 5 set assumptions. All these assumptions. Okay. Delete the original group. Yes, because I need the results. Yes, see. Pentula says how many, if you have two series, how many co-integrating relationship you may expect? For two series, we may expect one relationship. For three series, we may expect two relationship. Clear? One less than the number of series. My point
Okay,
is
madam.
clear or not?
Yes, madam.
Yes, I am going again. Quick group statistics, Johansson's co-integration test. Okay. I'm because we applied lag for 6, we will be changing this to 5. No. Sorry. How to check the lag? First, we have to apply. It is given in EVIEWS file 12. Participants, please download this on your system because it will not be available after 1 month. This EVIEWS registration is for 1 month only. There are PDF documents, help PDF documents, user guide 1, user guide 2. Download these. Clear? How to select lags for co-integration? Yes, it says apply var on levels. Apply var on levels. these three series, GS3, space GS5, GS10 space GS5. Okay, view lag structure, lag length criteria. It is monthly data, maximum lags we will be taking 12. Yes, AIC says how many lags to introduce? 8. For it is large sample, so I'll be going with SC criteria following the Walter Enders. Clear? If your literature says follow the AIC, then you follow the AIC. If your literature says follow SIC, follow SIC. Clear? If I go with SC, how many lags to select? 2 lags. 2 lags. If I go with AIC, how many lags to select? 8 lags.
8 lakhs.
Clear? Which one to follow? Yes, you decide. No issue. You have to go with literature. For example, our literature says SC lag. So I'll be going with 2 lags. Clear? This is the procedure. It is given clear cut in EVIEWS 12 guide 2, user guide 2, that apply the var on levels, select the lag length, and then for integration apply one less than this lag length. Clear? Quick.
Yes.
Group statistic, Johnson's co-integration. If I go with SIC, then for var in levels it was 2. I have to select one less than this, lag 1. Sorry, it's 41. 1 space 1. You have to write this 1 space 1. And summary all the, yes. Delete group, yes, delete group. How many co-integration equation can we expect? If we have, what is co-integration? See, if we can't apply this y is equal to a plus bx on non-stationary data. We can apply this or not. On non-stationary data, simple regression equation cannot be applied, because for all these models except ARDL, for linear model, for ARMA, for ARIMA, all the series should be stationary. Then what is the definition of co-integration? Co-integration says when we apply regression, when we regress one non-stationary variable on another non-stationary variable and residuals are stationary, then we can say that series are co-integrated. Clear?
Yes,
Should I write this? When we regress?
No, ma'am.
Clear? When we regress one non-stationary on another non-stationary series, and residuals are stationary, then series may be integrated, co-integrated. Clear? But for co-integration, there must be some logic. For example, lady and dog. If there is chain around the neck of dog, then we may say that steps of female and steps of dog may be co-integrated. If there is no chain around the neck of the dog, then we can't say that these two series are co-integrated. Clear? Clear or not?
Yes, ma'am.
There may be some
Yes,
reason, some logic why the series we can expect to be co-integrated. Clear? And number of co-integration is one less than the series. It is mentioned in many books, in almost all the books on time series. Clear? Number of co-integration is one less than the number of series or variables. All the standard books of time series mention this. Number of co-integration is one less than the number of series. Yes, Pentula says start from first. If you get if you get your desired number of co-integration equation, then go with this. If you don't get with first, then go with second. You don't get with these two, go with third. If you don't get these three, then go with four, then five. If you don't get with any of these, that means your series are non-stationary. See, we have three series. How many co-integration relation we can expect? Two. And with the help of trace test, we are expecting with no intercept, no trend. Yes. Now go to quick group statistics, Johansson's co-integration. This, which one we will select? No intercept, because this is the criteria which is doing what we want to, what we were expecting. So I am going with this and 1 and 1. Okay, lag is 1. Delete group, yes. Yes, none. At most 1, at most 2. Means there may be no co-integration equation. This has been rejected. There may be one co-integration. This has been rejected. There may be two co-integration. This cannot be rejected. Means there are two co-integration equations. Means all the three variables are co-integrated. Clear or not?
yes, madam.
Yes. Now, if these are co-integrated, see, I have written if these are co-integrated, then if Johansson's co-integration test are applied on non-stationary data, and if you find co-integration, clear? If you find co-integration, then apply error correction model. Clear? Then apply error correction model. Now, I'm going to apply error correction model. With these values, with these options, quick, estimate, var, error correction model. Our series are, which are our series? GS 3, GS 5, sorry, GS 3 space GS 5 space GS 10. How many lags to include? 1 lag. In co-integration, which one to select? Same that we selected in co-integration. Yes. Now we have given all the all the required options to the EVIEWS and go with C. Delete var. Yes, previous var you may delete. One thing. This error, what is the difference between error correction model and vector error correction model? When we have only two series and there is only one co-integration equation, it is called error correction model. If there are more than two series, it is called vector error correction model. This is the only difference. How to check whether the sequence we have written is correct or not? We have written GS3, GS5 and GS10. Whether this is correct or not, this coefficient should be negative and significant. It is negative, significant, but it should be less than 1. Point is clear or not? I am audible, participants?
Yes, madam, you are
Yes.
audible.
Yeah.
Yes, ma'am.
Four correct sequence. See, in quick estimate war vector error correction model, we selected GS3, then GS5, then GS10. This was our sequence. Whether this sequence is correct or not, it was 1, 1. See, it is given in estimates. It was 1, 1. It is co-integration we selected first. Whether this sequence is correct or not. If this sequence is correct, this coefficient should be negative, significant and less than 1. On the basis of T-stat. See, in these brackets there is T-stat. On the basis of T-stat, it is significant, it is negative, it is significant, but it is not less than 1. So we have to change the sequence of the variables. My point is clear or not? Other things
Yes, madam.
remain same. Okay. Now it is negative, it is less than 1 in 1 as well as in 2. It is negative, it is less than 1 and it is significant. Now sequence is correct. How to check whether the sequence of variables written in error correction model, it is correct or not? How to check? On the basis of this, first will always be 1. Always will be 1. You have 3 variables, 5 variables, 20 variables. First will always be 1. Clear? For this, for others, at least 1. For at least 1. We have 2 integration equations. So for 2, it should be negative, it should be less than 1, and it should be significant. Point is clear or not?
Yes, madam, it is clear.
It is clear. It is clear. Now our sequence is correct. We may interpret this. This is the table 4. This is the table 4, GS5. This is for GS10 and this is for GS3. In the same way, we will go with view, lag structure, Granger causality block exogeneity test. Same. Dependent variable D. Now it is D. D means difference. Means it has applied this on difference series. It is telling us, see this is telling us long run relationship. It is long-term relationship. Clear? And this is short-term relationship. Lag structure, Granger causality test. In short term, what is the relationship? D means difference. And when there is difference, means series is stationary, and in stationary series we can find only short-term relationship. For non-stationary series, if series are co-integrated, then we may find long-term relationship. See, dependent variable DGS5 in short-term relationship. The short-term, these are not significant. Means these two are not leading this GS5, but these are significant. Means these are leading GS10. GS5 as well as GS3 are leading GS10, and these are also not significant. Means in short term, these GS5 means 5-year interest rate and 3 years interest rate lead 10-year interest rate. But in long term, stat in long term, what is the impact? This GS5, other two variables are significant. In long term, on GS5, other two variables are significant. For GS10, other two are significant, but for GS3, other two are not significant. It is long-term relationship. This error correction co-integration equation 1, this is long-term relationship. Clear or not?
Excuse me, madam,
Yes.
please go to the short-term relationship model.
Which model?
No, the previous model, that is a short-term relationship model, difference model.
It was in view, lag structure, Granger causality. Yes. In short term, this is the
In
short
case
term
of, yes,
relationship. This is dependent variable. These may be excluded or not. Means these are important or not. Clear?
and next table, in this table, actually, madam, in this case, the variable D within bracket GS5 and D within bracket
D is for difference. D is for difference. Clear?
difference of GS5,
Difference of GS10.
and GS3. In case of GS10, where dependent variable is difference of GS10, and the difference of GS5 is significant, whereas the difference of GS3 is insignificant. But
It is the same case you are talking about, and overall it is not significant.
madam,
Overall,
this
it may be significant. You are talking about significant and not significant. It is not significant. Overall
yes,
model is not good, but GS5 is leading GS10 in short term. Clear?
okay, madam. Okay.
And if you have 0.0584, means you have near to 6, then you may say that it is marginally significant. Clear?
Okay, madam.
It is not significant because it is not less than 0.05, but it is greater than 0.05, but less than 0. Or equal to 0.06. You may say it is marginally significant. Clear? It is
Okay,
the
madam. But
interpretation.
actually, in this case, we can say the models individually significant, but in case of overall model, if we
Overall
take,
model is not significant. Yeah, it is the interpretation.
therefore, we have to take single variables as independent variable.
Yeah.
Okay, madam.
Yeah.
Thank you. Madam, I have a question. Actually, in
Yeah.
case particular book, the book was Principles of Econometrics by S.K. Bhomik. The author said that
Wait a minute. Principles of Econometrics by
by S.K. Bhomik.
S.K. Bhomik. Yes, I have the book.
Oh, okay, madam. Actually,
It is I don't recommend you these books. You go with the book Econometrics. If you want to learn good econometrics, go with I have quoted all these books. Go with my base book is Gujarati. Clear? My
okay,
second
madam.
book, I will be sharing the pics of all these. I have hard copies. I have Gujarati. I have Dogarti. Yesterday, someone was asking the question on dummy variable. Dogarty has a good interpretation of dummy variables. Go with Gujarati, go with Dogarty, and go with this Chris Brooks. Wonderful books.
Okay.
If you learn these three books and Walter Enders. Clear? I have many books. I have book by Green. I have book by Stoke Watson. Clear? I have many books. I have book by Hamilton. Clear? At least I have 20 books on time series and econometrics. But these three, if you learn from these three, you may learn many concepts of econometrics.
Yes, madam. Actually, I want to say something relating to co-integration equation. They said that before going to co-integration equation, we have to check the residual diagnostic, whether
Yeah,
the
we
residual
should
succession.
do residual diagnostic. We should do residual diagnostic for all the um, equations or all the models.
For all
Clear?
models.
Yeah. Generally residual diagnostic is clear in case of error correction model. Why it is clear? Because we have taken the we sorry we have taken the expected level or uh, the required level of lags. Clear? So autocorrelation problem is solved generally in error correction model. Clear?
Thank you.
But you should check residuals for uh, all the models you are going to apply.
Okay.
Yes. What are these AIC or BIC? What is R square? Last topic of today. Last topic of this workshop. What is R square?
Madam,
Hanji?
coefficient of determination.
What does it tell us?
Actually, it tells us the explanatory power of the model or the by
Yeah.
this.
You may say explanatory power of model or explanatory power of independent variables. For example, your students, you give a test to your students and your students score different marks. One is scoring 50%, other is scoring 60%, other is 40%, other is 90%, one other is 100%, and one with 70%. There is variance in these marks. Clear? It is total variation. The variance of a series is called total variation. But you
Yes,
want to find out what are the reasons for these.
yes, madam.
You,
This is known as trend variation.
yeah.
If we ever
Uh, for example,
find,
you see that some are day scholars and some are living in hostel. The students, those who are living in hostel, scored more marks than the students living in those who are day scholars. Then other reason is their previous semester marks. Other reason is your attendance in the class. Other reason is whether they attempted previous test or not. You find these reasons, you collected data on these variables, and you regress the marks of test on these four variables, whether the person is day scholar or living in hostel, whether he attempted previous test or not, what is his or her attendance in the class, and fourth reason was uh, forget this, you applied regression equation on these uh, three variables and you find that these are significant. Then this R square is telling you that out of those 100%, those 100% variance, how much has been explained with these three by these three variables. It is R square. Better
yes,
R
madam.
square or adjusted R square, almost the same. Adjusted R square, model with better adjusted R square is considered as better model. With high R
Yes,
square or high adjusted R square is considered better than the other models. It is the case, you all know. It is the case or not?
yes, madam.
Yes. Then means how much has been explained. It is R square. And these criteria, AIC and SIC or other criteria, these are on the basis of how much has not been explained. That is why we select the model with least of these. Clear? We select the model with highest R square and we select the model with lowest this AIC or SIC or HQ criteria. Clear? With
Yes,
lowest,
because
because
we
these
and
are based on the point that is
model.
not explained. Clear?
Yes, madam. These are based on error.
What?
Actually, madam, I want to say in case of information criterion, SIC, AIC, and etc.,
Uh,
these are based on error. That is the
yeah,
residual
these
part.
are based on error. These are based on error. Yeah, you are right.
Therefore,
Error means
Right.
not explained. Unexplained is
Not
called error.
yes,
Clear?
unexplained variation. Yes, madam. Therefore, we want to minimize. This is our
Yeah.
main objective, to
Yeah.
minimize the error.
Thank you all. This all
Thank
from
you.
my side. Hope you apply any of these models and you write a good paper, or you apply any of these model in your thesis, in your research. All the best to all. Thank you, Kavita ma'am.
Thank you,
Thank you all
ma'am.
the participants.
Yes, ma'am.
Thank you so
Thank
much,
you,
ma'am.
ma'am, for such an informative session for the
Thank you,
participants.
ma'am.
Your remarkable depth of understanding regarding financial econometrics using EVIEWS and NAR made the session exceptionally stimulating and informative one. We are extremely grateful, ma'am, that you found time out of your busy schedule to conduct the session. The knowledge gained from the session will definitely benefit the participants. Now, I would like to invite our director, ma'am, Dr. N. Malti, to and address the participants. Over to you, Malti, ma'am.
Good evening, ma'am.
Good
Good
evening,
evening,
Malti
all the
ma'am.
participants. It's always a pleasure to have you, and I often repeat that you've become a family with DIAS. So the people here or the organizers are changing, but nevertheless, your support has been unflinching. So and this time we've had a good response. In fact, but today I find that the numbers has come down, but being the last day, I suppose, and the fag end of the session, I think the numbers have come down, but I've been told that we've had quite a good participation and a lot of queries have been asked. And this time we've had participants from far and wide. So I take this opportunity to thank you once again, ma'am, for your knowledge sharing process. And this has been a continuous one. And I think there are a lot of researchers who, again, would value all the learnings that they've had and the takeaways that they have had to have better research being undertaken, and these are platforms where we can exchange ideas, network, and also learn what are the areas which are emerging and how do we deploy these techniques in these new emerging areas too. So a big thank you to you, ma'am, in particular, and all the participants who have been actively participating in the activity and have been constantly learning and sharing. We hope that this association doesn't stop here. All the participants are again welcome to share their knowledge with each other, and also we do have other platforms wherein you can share this. We do have our own journal also, DTR, which is a refereed journal. So we would invite participants to send their papers also to the refereed journal. I think Kavita would share the details. And in the end, I would also like to thank Kavita and Sakshi, who have been constantly working hard, along with Pratiksha Tiwari, who all of the entire team has been constantly working to ensure that we have a large number of participants, and there is a lot of sharing of information also. We hope that this association doesn't end here and it continues also in the times to come. So a big thank you to all the participants, and we would want to get your feedback, because for the organizers, the feedback is one motivating factor. For the resource person also, is the feedback is one motivating factor. So we would expect the participants to share their feedback, so that we as organizers also can again better what we do in the future too. So hoping to hear from all of you in some form or the other. And thank you so very much, ma'am, again.
Thank you, ma'am. It has always been a good experience to work with DICE. Kavita and your appreciating words always motivate me. Kavita
Yeah,
is a very good person.
yes,
Yeah.
yes. She's been constantly again taking
Yeah.
care of all of them, Sakshi
Uh,
and Kavita. I
yeah.
hope Sakshi again is here. And can we request the participants to, have you had a picture, Kavita? If we can make a request to the participants to just switch on their cameras for all those
Yes.
to whom it is possible, I would say. Yes.
Participants, if you can switch on your cameras, then we can take some pictures for the FDP.
Ma'am, we hope we are not troubling you.
I'm not able to because I am in comfortable
So,
dress.
the
Yeah.
others, all the other participants, it would be again a pleasure for you if you could kindly switch on your cameras so that we can just have one picture. Okay. So I think there are a lot of reservations. Nevertheless, we can have the pictures with the ones who have again switched their cameras on. And yes, Sakshi and Kavita, thank you so very much. I think Pratiksha couldn't join us. So that's all from us, and we hope to hear from you on many occasions, because we do have series of activities being organized at the institute.
Thanks, ma'am. Thanks, Dr. Kavita. Thanks, participants. Please
Thank
share fair feedback.
Yes,
Thank you
that's
so
All
much,
of
ma'am.
you, please share fair feedback. It will motivate us. It will give us the chance to improve me as well as the organization.
yes, that's true.
We
That's true.
expect fair
Yes,
feedback. Yeah.
Yes.
Thank you. Thank you,
yes,
ma'am. Thank you all.
participants, I'll be requesting one. Yes, participants, I'll be requesting one Google form with you, in which you are required to fill exact credentials which you want in your certificate. So we won't be able to change it at a later stage. So all are requested to fill that feedback form, the feedback form, and the form which I'll be sending for the certificate.
Okay.
Thank you.
That's all.
Thank you
Thank
all.
you all.
All the best.
Thank you, Malti
Thank you,
ma'am.
ma'am. Thank you, Kavita. Thank you,
All the
Sakshi.
best.
Bye.
Thank you, ma'am.
Thank you very much, ma'am.
Thank you,
We all
participants.
may leave now.
Thank you, ma'am.